So question 13 from the practice exam, we've got iron 3 oxide reacts with carbon monoxide to produce iron and carbon dioxide. They're asking us, right, this is a redox reaction, identify the oxidized and reduced species in this reaction, as well as the oxidizing agent and the reducing agent in this reaction. So anytime we have a pure elemental solid, right, the oxidation state is 0. In the iron oxide, right, it's iron 3 oxide because I can break that down to say, all right, I have 2 irons, I have 3 oxygens. Overall, it needs to be neutral. I go to the periodic table, right? Oxygen is always -2 as an ion. So that means the total charge from oxygen is -6. That means I need to have a +6 charge from the iron. Split that over 2 irons. So each iron is 3+ each. So that's one reaction that's taking place, right? I've got iron that's 3+ is reacting to go to iron 0. And then my other reaction is a little bit harder to see, but I can do the same thing. Basically, in carbon monoxide, oxygen is always -2. So carbon needs to be +2 to balance that out. So what does that mean in carbon dioxide? Well, I've got 2 oxygens at -2 each. So carbon has to be 4+ in carbon dioxide because my total charge from the oxygen is -4 on that. So my other half of the reaction is going to be carbon monoxide goes to carbon dioxide, right? That goes from 2+ to 4+. And I had 3 of those, and I have 3 of those. So how do I balance these reactions out? What's happening to the iron 3 oxide when it goes to iron 0? Yeah, it's gaining, right? It has to gain electrons, so it's going to gain a total of 6 electrons, right? Because each iron goes from 3+ to 0, and I've got 2 irons, so 6 electrons total, right? And then what's going to happen to my carbon in carbon monoxide for it to go from 2+ to 4+? Yeah, it's going to lose 2 electrons each. I've got 3 of those, 3 times 2, right? Plus 6 electrons. So, all right, iron is gaining electrons. What's gaining electrons? All right, that's my reduction reaction. Iron is being reduced, it's gaining electrons. And then my oxidation half reaction, carbon monoxide is being oxidized because it's losing electrons in that reaction. The next thing we have to do, what is my oxidizing agent and my reducing agent? Those are always flipped, right? Oxidizing agent is called the oxidizing agent because it causes oxidation. It itself gets reduced. So iron 3 oxide is my oxidizing agent, and that would mean carbon monoxide is my reducing agent. It's causing reduction by getting oxidized itself, and this is where it originally came from, because you want to think about oxidation, you're thinking about you're creating more bonds with oxygen, you're going from CO to CO2. Typically, when you're adding in more oxygen, right, you're oxidizing that. So yeah, we're oxidizing carbon. In this reaction, carbon though is our reducing agent. Carbon monoxide is our reducing agent.
And why do you put the iron oxide in like the half reaction place? Why do you put like why don't you just want the iron? instead of?
Yeah, I could have, and I thought about going back and erasing that. So you're saying, just writing it as, 2 iron, 3 plus, yeah. 2 iron, 3 plus, gains 6 electrons total to go to iron 0. But the end of the day, they're asking for is it iron 3 oxide, carbon monoxide, iron, or carbon dioxide. So in the end of the day, for the answer, right, they're looking for carbon monoxide, they're looking for iron 3 oxide, because that's, that's the whole species in the reaction. That's, even though it's just the iron that's gaining or losing, gaining electrons.
Okay, and on the test, this question would come, up, you can put like, like it could be like broken down, like if it were aqueous or something, to break it down to ions and then.
Yeah, if it was aqueous as ions, we can break it down as ions in solution. Here, they're all solids or gases, but we can still assign an oxidation state, right? Because we still know any pure elemental solid is 0. Any diatomic would also be 0, like hydrogen gas or chlorine gas, right? All molecules need to be 0, and that's how we're able to figure out, carbon dioxide. Well, carbon, I've got 2 oxygen. Oxygen is always -2, so that's a total charge of -4. The whole thing needs to be neutral, needs to be 0. So, okay, carbon needs to be 4 plus to balance that out. So even though it's not aqueous in solution, we can still assign charges to figure out what's being oxidized or reduced in this reaction.
Yeah, I'm just confused by like that part. So is carbon not a negatively charged, or are you just assuming it's positively charged in this situation?
It's changing oxidation state in this reaction. It's not ionic, so it's not like sodium chloride where there's an official charge there. We're just kind of like temporarily assigning a charge to it. So we're just treating it like it's ionic, even though it's not. So we know oxygen is -2. Okay, to balance that out, we're going to assign this +2 charge to carbon. Yeah, it's not really carrying a charge. It's not an ion in solution, but we can assign a charge based on how many oxygen it's bonded to. Same thing here. We've got 2 oxygens to 1 carbon. So now carbon went from 2 plus to 4 plus. So we're kind of, even if it's molecular, we're treating it like it's ionic and just assigning some charges. Yeah.
So what would be the oxidizing agent?
Right, the oxidizing agent was what I originally wrote out, the iron 3 oxide. They give you 4 choices, right? They give you, this would be my oxidizing agent. Yeah, even though it's iron within there, we can't just put iron 3 plus in the reaction. It's the iron 3 oxide that's in the reaction. All right, we've got time for like one more question. Or we can leave 6 minutes early, that's fine. Yeah,
I mean, this is back on the homework.
yeah,
Okay.
if no one else has a question.
Yeah, even 39 and 44.
Regret opening my mouth, saying anything. 39 or 44.
Yeah.
So 44 is a lot like this question here, right?
Okay.
The zinc is reacting with HCl again. There's a temperature change. They want to find the heat of the reaction per mole. So yeah, that's 44 is going to be almost exactly like this, except for you got a different mass of water, a different mass of zinc.
Okay.
And then 39 was the other one. Oh, okay, so a thermochemical equation. Didn't just stop recording.